Bright Tuty. Every student matters.
Let us see the next question. Okay. What is exactly given in this question is a bus starting from rest. If a bus has started from rest, that means its initial velocity is 0 because initially it was at rest. So, initial velocity is 0 as bus was at rest. It moves with a uniform acceleration of 0.1 meter per second square. The acceleration is given to me to be 0.1 meter per second square for 2 minutes. Time is given to me to be 2 minutes. I need to convert it into seconds, comes out to be 2 into 60 seconds or 120 seconds. Now, find the speed acquired. What I need to calculate is to find first thing is final velocity. I need to calculate the final velocity small v and the distance travelled. I also need to calculate the distance travelled by this particular bus, right? And of course, both the things I can't find from any one particular equation. Fine. So, what I can do is to find v, I will use the first equation of motion because u, a, t are given to me. So, we know that v is equal to u plus a t, that is from first equation of motion. Putting the values, what we will get is v I need to calculate, u is given to be 0, a is 0.1 meter per second square, multiply by t is 120 seconds. Removing this decimal 10, cancelling it out, v comes out to be 0, remains insignificant. This comes out to be 12 meter per second. This is my u, sorry, v, alright. Now, when I know the value of v, now simply I can calculate. We know that v square is equal to u square plus 2as. This is the third equation of motion. Now, in this particular question, we actually never required this thing to find out just for the sake of calculating distance. Why? Because we could have calculated separately with the second equation of motion also, s is equal to ut plus half at square, because everything u, at were given, right. So, that is one or the same thing. But one thing importantly is we cannot calculate both the things, final velocity and distance, through any particular one equation. We had to use two equations. V we have just found out 12, we will keep the square, u is given to be 0 plus 2 into a is 0.1 multiply by s. So, removing the decimal, cutting it off. So, this 0 becomes insignificant, this 12 square becomes 144 is equal to, this is 1 by 5s, s keeping here cross multiply, I will get 144 into 5 by 1, s or the distance travelled comes out to be 720, SI unit is meters. So, this is my distance travelled. Got it? Fine. So, these are a few type of questions that we have seen. All the rest of the questions will be basically the same. Let us now see how exactly he is changing the language. That is it. A train is travelling at a speed of 90 kilometers per hour. This is the initial velocity given to us, right. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. This is the acceleration or retardation because it is minus. Find how far the train will go before it is brought to rest. If the train is brought to rest, the final velocity given out to be is 0. How far means we need to calculate the distance. Got it? Fine. So, let us see what exactly is given to us in the question? The initial speed or the initial velocity of the train is given out to be 90 kilometers per hour. Converting it into meter per second, 90 into 1 kilometer. Rather than writing 1 kilometer, I can write 1000 meters divided by 1 hour, which is equivalent to 3600 seconds. Cancelling out the zeros, 9 1 the 9 4 the and 4 1 the 425 the, that comes out to be 25 meter per second. Right? Uniform acceleration or retardation is given to us in the question. This is retardation, which is minus 0.5 meters per second square. Right? The train is brought to rest, that means the final velocity is given to us v, that is 0. We need to find the distance travelled, s. Right? Now in this question, what exactly we are being given? We are given u, we are given a, we are given v. So if I need to find out s, what I'll apply is, I'll apply the third equation of motion. We know that v square is equal to u square plus 2s. This is our third equation of motion. Right? Fine. Putting the values, I am given v is given out to be 0, u is given out to be 25 plus 2 into the value of acceleration is in minus because it is retardation, multiply by s. So it comes out to be 0 is equal to 25 square is 625, plus and minus becomes minus 2 into 0.5 into s, removing the decimal and just putting out 10, 2 1 the 2 5 the, cancelling it out, we will get 0 is equal to 625 minus s. Taking s on the other side, I will get s is equal to 625, keeping the SI unit meters. I will see that the distance travelled by this particular car or object is 625 meters. Right? So this is the question. Alright, it is a train, not a car, a train. So this train is basically going to travel a distance of 625 meters before it is brought to rest. Fine. I hope you have understood what exactly and how exactly we have done this particular question. Right? Fine. Let us see the next question. Now what does this question say is, a trolley while going down an inclined plane has an acceleration of 2 centimeter per second square. So this is something new you are encountering in this question, that now the acceleration is given out to be centimeter per second square, and we know that it should be in its SI unit, that is meter per second square. So simply we need to convert it. Alright, we will see how. What will be its velocity 3 seconds after the start? Now what all are given to us in the question? First of all, the time is given to be 3 seconds. Time represented by small t is given to be 3 seconds. After the start, the body is at rest when we are talking about, because it is being starting, right. So we know that whenever a body moves from its rest or starting position, then in that case we take the initial velocity to be 0, because the trolley is at rest. Here the trolley starts. Alright. So next thing given to us is acceleration. Now this acceleration, small a, is given to be in centimeter per second square. Right. So we need to convert it into meters, and how we can do it? We know that there are 100 centimeters in 1 meter. I can write it as 2 into 1 centimeter per second square. and rather than writing centimeters, getting it converted into meters, what I need to do is I need to divide it with 100, then it will become meters second square. So this becomes 2 upon 100 meter per second square. I can write 0.02 also here, but again while doing the calculation I will be removing the decimal. So let it be like this right at the moment. For the time being, we will see how to do it, right. So now my time is given, initial velocity is given, acceleration is given, and what I am supposed to calculate or to find is the final velocity, that is the velocity after 3 seconds, right. This is what I am supposed to find, right. This is what I am supposed to find. How will I do it? We know that we need to apply the equation of motion for doing it. So we know that we can find V from the first equation of motion. We know that V is equal to u plus at. This is our first equation of motion. Now putting the values of u, a and t, what I will get is V is equal to, u is given to be 0 in the question, acceleration we have just calculated 2 upon 100 multiply by 3. So V is equal to, this is 3 into 2, that means 6 upon 100, that is meter per second, right. So the final velocity of this particular trolley will be 0.06 meter per second. That will be my answer. Got it? So in this question we have seen that the only thing we need to remember was to take care of the unit. Acceleration was given to us in centimeter per second square. We need to convert it into meter per second square, right. Now students, in this next question you need to relate a new concept, and that new concept is, if till now we have seen that the body is basically traveling along a straight road, linear motion we have talked about, right. But now in these type of questions we will be given that either a body is thrown upwards or from some height the body is an object is dropped. Now one thing that we need to remember is, whenever we are dropping an object, whenever is an object being dropped from some height, in that case we assume that its initial velocity is 0, because initially the body was at rest. So whenever we are dropping any stone or ball or any object from a height, we will always assume initial velocity to be 0. Second important thing that we need to remember is that whenever an object or a particular body is thrown upwards, fine, whenever we are throwing a body upwards, then that particular body is going to achieve a particular height. Whatever maximum height it can achieve depends upon the force with which we are throwing it upwards, but there will be a time after which this body, after attaining its maximum height, is going to come down because of the force of gravity. We cannot throw an object with our hands which can defy gravity and can directly go into the outer space. We don't have that much of force, right. Even do we send the satellites and the rockets, everything like that only, but for that we require fuel which burns and provides that rocket that particular acceleration with which it defies the force of gravity and goes in the outer space. But when we are talking about the numericals, we are just talking about throwing the object manually with hands, so we don't provide that much force. So we assume that with whatever force we are throwing this particular body, it will just achieve some height, and at that particular height, maximum height, that particular object is going to stop for a fraction of second, right. So ultimately whenever a body or a ball or a stone or an object is thrown upwards, then in that case always its final velocity we will take to be 0. Why? Because at that particular point, just for maybe even a fraction of second, but the ball or the object stops. It will stop, because then it will come down, right? So, whenever a body is thrown upwards, we will always take v or the final velocity to be 0. Another thing, whenever we are dropping this particular object, then in that case the acceleration, whatever the acceleration with which it is coming down, it is actually under the acceleration due to gravity. Whatever the acceleration it is coming down, it will be positive. It has to be taken to be positive. Why? Because the force of gravity pulls all the objects towards itself in the downward direction, and the direction of motion of this object is same as that of the direction of gravity, right? But whenever we are throwing an object upwards, then it is going against gravity, because gravity acts in the downward direction and it is acting against gravity. In all such cases, we will take the acceleration to be minus. Fine. We will take the value of acceleration in minus. The acceleration due to gravity is acting on it, it has to be taken in minus. So, whenever a ball is dropped from a particular height, we will take acceleration to be positive, and if it is so called thrown upward, then in that case the acceleration is to be taken as negative, right, whenever it is thrown upward. So, these are the three things you need to remember. Fine. Let us see now what exactly our actual question was. A stone is thrown in a vertically upward direction. Now, the stone is thrown in the upward direction with a velocity of 5 meter per second. So, this is the initial velocity of the stone with which it is thrown upward. So, initial velocity is given to us to be 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square, acceleration is given in the question to be 10 meter per second square, but since we know that we are throwing the stone in upward direction, we take the acceleration to be negative, right? Alright. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction, because acceleration is, the stone is moving up, what will be the height attained by the stone, right? Now, if I am talking about a linear motion, straight line motion, this point A to point B, the distance is A to B, we call it distance, right, the path moved. But when we are throwing something up or down, the same path covered by the object will be known as its height. So, height or the distance, they are taken to be a same thing. Distance is basically when we are talking about linear motion, and height is when we are talking about the vertical motion, right. So, the height we have to calculate, or we will say that we need to calculate the distance travelled by this particular stone. This we have to calculate, and how much time will it take? We need to calculate the time. This is what we need to find. Now, one more important thing, when the stone has been thrown in the upward direction, we have just studied that we will take the velocity, the final velocity to be 0, right. This will be 0. Now, the things are pretty much clear. We need to calculate the time and the distance. The information details are given to us. For calculating time, I will apply the first equation of motion. We know that the first equation of motion states that V is equal to U plus AT. I am provided with U, V and A. I will calculate T. Putting the values, V is given to be 0. U is initial velocity is 5 meter per second, plus A is minus 10 meter per second, and multiply by T, right. So, 0 is equal to 5 minus 10 T, taking 10t over here on the opposite side, this minus will get converted into positive sign, this will be equal to 5, and then taking t here and 10 in the opposite direction, I will divide it and I will get 0.5 second, right. So, this will be the time taken by the stone to reach that particular height, right, with that particular velocity. Second thing we need to calculate was the distance. Now, we know that calculating distance, the formula is the equation of motion I will apply. Third equation of motion, v square is equal to u square plus 2as. Now, again putting the values in the equation, v is given to be 0 in the question, u is given to be 5 meter per second. I will take the square plus 2 multiply by acceleration was minus 10 meter per second square and multiply by s. So, this comes out to 0, 5 square is 25, plus and minus will be minus 20 into s. I will take 20s to this side, left hand side, I will this convert minus into positive sign, this will be 20s is equal to 25, s is equal to 25 upon 20. That comes out to be simply 1.25, right. This is 1.25. We are calculating the distance. So, the SI unit will be meter and answer will be S is equal to 1.25 meter. Got it? Fine. So, these are the things you need to remember. Next, when an object is dropped. Now, in the next question, what exactly is given to us is a ball is gently dropped. Whenever an object is dropped from a height, we have studied that we will take its initial velocity to be 0 from a height of 20 meters. Now, the height or the distance, right. I have told you the distance between the height and difference between the height and the distance. Height is vertical, distance is horizontal, both are the same thing. I will represent it with h or s, it is one of the same thing, that is given to be 20 meters. If its velocity increases uniformly at the rate of 10 meter per second square, meter per second square is the SI unit of acceleration. So, acceleration is given to be 10 meter per second square, which is in the downward direction. I will take it as a positive. With what velocity will it strike the ground? I need to calculate the final velocity. I will calculate the final velocity, that is v, which I do not know, and after what time will it strike the ground. I also need to calculate the time. So, once again we can find the requisite details using the equations of motion. We know that, what do we know? First of all, we will see the time part. We know that S is equal to ut plus half a t square. S or h is given to us, u is given to us, a is given to us in the question. S is 20 meters is equal to u is 0 multiply by time. We need to calculate, anything multiplied by 0 is 0, we know that, plus half into a is given to be 10 multiply by t square. So, we are left with the equation 20 is equal to this all is 0. So, this will be equal to 5 t square, or t square will be equal to 20 upon 5, which comes out to be 4. T square is equal to 4. Therefore, t will be square root of 4, which will come out to be 2 seconds, right. So, the time taken will be 2 seconds. Got it? Second thing we were required was to calculate v. So, now when we have got the value of time, we know that with the first equation of motion, v is equal to u plus at. V we need to calculate, u was given to us to be 0 plus a is given to be 10 and the time we have calculated is 2. So, v will be equal to 10 into 2 will be 20 meter per second, right? Fine. So, this is our final velocity. Got it? Alright. Next question. Let us see. A motorboat starts from rest. If the motorboat is starting from rest, we have done many questions. So, now we easily know that it means that the initial velocity is to be taken as 0. Now, the motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3.0 meter per second square. So, acceleration is given to us to be 3.0 or simply 3 meter per second square for 8.0 seconds. Time is given to be 8.0 seconds or simply 8 seconds. How far does the boat travel during this time? What we need to calculate? We need to find out or to calculate the distance travelled by the boat during this time. What we are given is UANT. Fine. And we need to calculate the distance. So, what we will apply? We will apply again the equation of motion, and in this case I will apply the second equation of motion depending upon what information or values were given to me in the question. So, I will apply this second equation of motion. Putting the values, I will calculate simply the value of distance. U is given out to be 0, multiplied by t is 8, which is irrelevant, anything multiplied by 0 is 0, plus half multiplied by acceleration is 3 multiplied by t square, which will be equal to 8 square. So, I will be getting S is equal to half into 3 into square of 8 is 64. Cancelling it out, I will get 32. So, the distance covered will be equal to 96 meter. This will be my answer. Got it? So, these are a few questions based on the equations of motion, all the three of them. Depending upon what exactly was given to us, we calculated whatever value was being asked to calculate, right? Please practice these numericals properly and thoroughly. All right. Thank you.